Hello, everyone. Welcome to Pivot 0x Hub Masterclass. Once again, my name is Shantanu Sharma, and I head the operations at Pivot. For all those who do not know about us, Pivot is a global Web3 startup venture accelerator firm. We mostly focus on accelerating early stage startups in this space. I will be talking about it more later, but I think I'll share my social links also in the chat. As far as 0x Hub is concerned, we are an open masterclass initiative where we want to enable the Web3 startups and aspiring founders with the knowledge from within the industry. And it is not only for the startups that we are accelerating, but for every other person in the Web3 space as well. All our sessions will be led by experts or people who are experienced in the field. So it could be founders, investors, angels, and many more. Today is the 14th masterclass, and we aim to do at least two every month on topics related to technology, between sectors, products, goals, leadership, product development, etc., etc. Everything that can help startups in a more 360-degree way. So we started this new series of masterclass called Build with Founders, in which we will conduct masterclasses on the business side of the young founders from the startups that we accelerate. So they will be talking about the tech, they'll be talking about the business and how the Web3 space can benefit by using or working with them in the technology. So the more beneficial kind of stuff that we're trying to do. Today, it's my pleasure to welcome Akshat Mishra. He's the CTO of Quill AI Network. It's a brilliant startup, which is under our acceleration program. They are pioneering a trust and security orchestration layer of Web3. I will leave the rest for Akshat to talk about it. All over to you now, Akshat.
Thank you for the introduction, Shantanu. My name's Akshat. I'm the CTO of Quill AI Network. And what the Quill AI Network is, what we're calling it, is the trust and security orchestration layer of Web3. Today's topic is somewhat connected to it. So without wasting much time, I'll jump right in and explain what we're talking about. So before we even begin about rebuilding trust in Web3 security, let's first try and understand what is trust and why do we need to rebuild it in the first place. So this comes from the thesis that blockchain networks and anything inside Web3 is supposed to operate in a trustless manner, whether you're interacting with a smart contract, whether it is an EOA, whether you're sending transactions to the blockchain network, all of it happens in a trustless manner. And it happens in a trustless manner because of the cryptography algorithms that are there in place to make sure that everything is done just as it should. But this presents us a paradox. Like while the core network and the core things about the protocol do operate in a trustless manner, the users still need to trust the applications that they interact with. And I'll show you what I mean. Let's take Uniswap as an example, or any other app that you guys use. Now, most of the users don't really care about the code that goes behind into the app or how it is being made. Most of us just put the assumption that it's from a well-known company, it's going to perform as well, and I'm not going to lose my funds. Now, there's a presumed trust in the applications that we use, but it's not the same when we are doing it directly with the blockchain systems, and it should not be, because the core network protocols, they have been built to work just the way they should, and there's no other way that they can work. But on the application side of things, the things are very different. On the application layer side of things, people have the absolute freedom to build whatever they want, and they also have the option to not verify it. So there are two things to this. You can build your application just any way you want. That means people have the option to code malicious things into the contracts, which most people will often overlook. Now you have the option to verify these smart contracts, but that still does not secure this for the end users, because we do not expect the end users to diligently go through every single app and the source code and find what's going wrong with it. Now, this has another facet as well, and that's about audits. So the whole entire goal of audits is to make sure that a project is secure before it goes live. But we have often seen that projects do get hacked even after they're audited by several companies. And the way these audits are done themselves present a flaw, because they also work on the assumption of trust. So let's say I build my own project and I decide to share it with an auditing company, let's say Quill Audits. Now I'm trusting the Quill Audits company to accurately present me the findings of the vulnerabilities and not keep it with themselves, because on the other hand, this is what could happen. I send my code to Quill Audits to audit the smart contracts, and one of the auditors finds a bug. Now they decide to keep this bug to themselves and not report it. And I, as a client, get my audit report, which looks to be safe, and I deploy my smart contracts. Now you would know what happens after this or what follows, depending on the TVL of the project. So it's all about managing the cryptoeconomic security. So the idea that I'm trying to present here is that the whole entire blockchain ecosystem is very hostile towards end users. It's more so saying you're on your own. You have to bear the responsibilities of your own transactions. Whatever actions you take, it's totally onto you. And since there's no intermediary in the blockchain system, because it's all going to happen in a trustless manner, there's nobody to stop you. There's nobody to stop people from scamming each other or to make apps or dApps that resemble the real looking ones or are phishing. So yeah. Now, I don't need to explain, I think, why trust is critical, but I'll highlight a few points. Now, for the longest time, DeFi's TVL has been stagnating. For the last 3 years, it has been around $7,200 billion, and we've not been able to move past that. And that means no new money is coming into DeFi projects. And that is quite alarming. If we don't get any more users, Web3 is not going to grow at the pace that we expect it to be. And this is primarily one of the reasons which wards off all the investors or the institutions who are looking to invest into DeFi protocols, because it's a high risk asset, and the risk is not just economic, it's also related to the overall security of these systems. The end users, they're highly exposed and unprotected, and they bear the brunt of the most of the hacks that happen, which often result in the losses of private keys through phishing apps, through whatever means. So there are plenty of ways the end users get hacked, and there's nothing that's embedded inside wallets to protect them. Now, the loss of funds also affects the credibility of a protocol owner. Let's say I build my own protocol and I get it done through an audit and it goes live. There's still a chance that there are bugs in the code, and if there are, once it goes live, there's nothing I can do about it, except if maybe I can upgrade it. But even then, it does not ensure or fully ensure the security of the end users or of my own protocol. So these are some factors which I feel are coming in the way of Web3 scaling to the next billion users. So security and trust is not just it's not just about security, it's a UX problem altogether if you look at it that way. Now, AI changes the game, and I'll specifically mention why AI. So most of the things in Web3 is code or things that are related to understanding of the code, whether it be understanding the different apps that you're using or smart contracts that you're using. If somebody is able to understand what the code really does or what it means, what it is trying to intend, then they can figure out whether it's malicious or not. But most users do not have the ability, or you should not expect them to be diligently going through every single dApp that they look for. The dApps that they should have access to should already be secured, and there should be no room for any hacks or attacks. So AI, especially transformer models in particular, have a really good ability of understanding code and forming complex relationships. So at the Quillia network, one of our agents that we are building is called Quill Shield, which is an AI-powered smart contract auditing tool, and it has been fine-tuned on a data set. So what it is capable of doing is it can audit smart contracts just as good as a human auditor would, and we're taking it to the next level. So taking that thesis forward, we can use LLMs to sort of look through these smart contracts and understand where if there's any hidden intent within these dApps, within these protocols. And if there is, we present it to the user. Now, again, why we need AI is because it can stay updated to the changing trends. And all it needs is new data feeds. And those are processes which can seamlessly merge together with AI once you decentralize the process of training these models. And this is as opposed to algorithms, which might get very complex if you were to write them, because all of it is data and all of it is on chain. If you were to write algorithms to assess all of that data, not saying you can't do that, but scaling that in a way where it is also economically incentivized is going to be difficult. So the approach here rather should be to build agents which are going to secure Web3, and anyone can contribute towards the security of these agents themselves by contributing code or providing the infrastructure to run them. Now, on the point of infrastructure, it's very crucial. Now, what we basically discussed in the last slide is the problem to the paradox of security, where between you, the end user, and the blockchain or the dApps, there's an entity, and that entity is an AI model, or it's an agent that's helping you assess the security of the transactions or the dApps that you're interacting with. It's sitting right there in between. And what's pretty about this is that if it is built correctly, it can be integrated into every layer of the Web3 fabric, be it the network level RPCs as well, which I'll come to later on why we would need that, but it can be integrated at any level. But then there's a problem to this, because these AI systems themselves need to run, sit, and execute somewhere. And that should ideally be a decentralized system itself. It cannot be centralized. If it is centralized, then it again brings the whole other security problem angle, where we're just losing the aspects of decentralization for security, and that's just not a good way to go. So what we can do here is use crypto as a layer beneath AI, where we have node operators who can run these agents in a decentralized manner, and they'll be incentivized for it. Now, how we can ensure that these things can run safely and that the operators themselves are not going to do anything? There are a couple of ways, but the first step is to ensure that there is strong economic security. Basically, the whole idea behind EigenLayer is that it borrows the security of Ethereum, which is the most decentralized L1 on the planet right now, and bring it to other decentralized networks or anything that you would want to build in a decentralized manner. Now, we can use this idea to create a slashing contract in such a way that it would slash the node operators if they run the nodes incorrectly. And if the nodes are run correctly, if the outputs are produced correctly, then they'll be incentivized. But there are more problems to it, because we also have to manage the privacy of the transaction data or any task data that comes to these agents and make sure that it's not misused. And the idea goes back to the idea of audits happening through agents, and those agents could themselves use it in wrong manners. Let's say your smart contract goes live on a mainnet. One of these agents or the nodes who's running these agents could simply take away that data and keep it to themselves and later use it to cause an attack. So how do we prevent that? And how do we make sure that the code is getting executed just as it should? Now, the idea is about blind computing, or more traditionally known as confidential computing, where you use trusted execution environments to execute this code. Now, what a trusted execution environment is basically a piece, it's a hardware piece on a platform, which is going to ensure that the code that's running inside of it matches the compiled source code, and it's going to match the two things. So if there's any change that the node operator tries to do to the code, it's going to be detected. And it's verifiable. So that means every time anyone changes the code, it's going to change the signature. So this basically cuts off the possibility that somebody could change the agent's code to run in a different manner. Now, this can go together very well with federated learning for AI. Now, the data that's contributed to AI, it can be contributed directly, but a lot of it is going to be IP-based data that you would not want to share publicly. So in those cases, federated learning comes in very handy. And it's a very simple concept that goes back to training the models from your keyboards for the next word detection. Now, how it works is, let's say there are 5 different users with different phones, and each of them is using their own phone, and they have their own recommendation system for the next word. And it's trained and predicting that based on the data of the user, based on the patterns. Now, how it works is that each of these different devices, it is training this data locally for its own user. And this data is then, not the data, the weights of this entire training is finally shared with one supermodel, which goes to Google. Now we can use the same idea in Web3 security and training our AI models, which will ensure that the task privacy is preserved, that the data privacy is preserved, while the training still happens. So our model still learns, but we do not get to see what it is learning on from. And these two ideas can come together beautifully in securing the whole ecosystem end to end. Now, I would like to present a few case studies and how there are different ways we can protect the end users of Web3 and the protocol owners. So one of the first studies that I want to present is of an audit and insurance protocol, which we are currently already building as an ABS. And how it works is very simple. We basically break it down into two main cycles. The first cycle ensures that the contracts get audited on the testnet. Now, on this testnet, we audit the smart contracts through our ABS, through a decentralized network, and other ABSs ensure that the audits are being done correctly. Now, once these audits are shared, we provide a risk score associated with it. And according to that risk score, people can choose the premium insurance that they want, and the coverage will be decided on those factors. Now, once they deploy these contracts on mainnet, the same coverage scores will be used to provide them insurance for the same instances of contracts that they had on testnet. Now, this will ensure that their contracts stay secure and they're getting audited through AI. Now, another aspect that I failed to mention previously, which I missed, is that the traditional audits are very slow and insecure, and the pipelines are mostly choked. And I'm saying that working in an auditing company, we have a lot of audits coming up to us, but we are not able to get through all of them because there's a lot to do and the projects take time. They're very complex. So that's another problem that AI can definitely benefit us from. But really, the coming of audit and insurance together in a platform is the key to securing the code and making sure that even if things go wrong, we still do provide you security in the form of insurance. Now, the other study is of a due diligence platform. We have something for this already. We call it Quillcheck, although it's not running in a decentralized manner. Now, this could be an AI agent which will provide you trust scores and risk assessments. We do this on our platform where if you, let's say, you have a token and you don't really know whether it is coded with a honeypot. So what you can do is you can simply paste the address of the token onto the platform, and through our LLMs and through our own mechanisms, we will ensure that the code has no hidden mechanisms to scam you. Now, this can be integrated directly inside wallets or in a blockchain network level itself to make sure that every contract that goes through is not a honeypot. It cannot scam the users anywhere. So it's the integration that is the key. And the way that all of it has to execute is through AI, which is running on a decentralized set of nodes. Now, the last study that I want to share is of a wallet guard. Now, this wallet guard can be integrated seamlessly within wallet apps, and it will screen every transaction. Now, every transaction has an intent based on what it's trying to do or what it's trying to ask for you. Let's say you connect to a Dapp, and the Dapp asks you for an approval of a transaction. But you don't really know what the transaction or what the consequence of the transaction would be unless you click on it. So what we can do here is make use of AI to understand the intent of the transaction to make sure that it's safe to go before you click on approving it. So this could again be integrated right inside your wallet through the APIs of our Quillcheck network. And what this would do, it would tell you the intent of the transaction and what it's going to do to your dApps and if it's safe to go. So by creating these different agents and creating an ecosystem which is embedded in every layer of Web3, we can definitely ensure that all the different stakeholders are secure. I want to get back to this for now and talk about the discovery of hidden patterns. So LLMs in particular have this ability when they're trained on large amount of data sets that they're able to figure out different connections between different topics, between different ideas, even though they have not been trained on it before. And this is especially like true on the case of encoder-decoder based transformer LLMs, which we will be using. Now, this will be able to detect hidden patterns inside the code and inside transactions and make sure that everything happens smoothly. So it's the coming of all of these different agents that can secure Web3 altogether. And the agents themselves need to be executed in a decentralized manner while ensuring task privacy and ensuring that the agents are performing the task correctly. So this was a really short, I guess it was a brief thing about what we're trying to build. And I guess that wraps up this masterclass. I hope you guys enjoyed it, and I would love to I love to look forward to what we're building next, and hopefully we'll collaborate.
Thanks, Akshat. I think a few things that everybody learns in every of these startups, in every of these masterclasses, is that Web3 is absolutely big and huge. Okay, and there are multiple different ways that people can actually, work in this and collaborate together. I just want to open the floor for any questions. Are there any questions that any of these people have? If yes, please raise your hand, and we can allow you to come and talk to Akshat directly.
Hi, Akshat. Prashant here
Hi,
from Zero
Prashant.
State. Yeah. Akshat, just want to discuss the case study that you were showing with audit and insurance protocol. I mean, I get the whole gist. Of course, AI agents can audit the smart contract, but I'm curious to know how are these AI agents are vetted and verified? Because whatever the
Right.
concern that you have with the manual part could also happen with agents. I mean, it's the model, right? We can use
Definitely.
it, right? So
Right. So how we are solving, I'll give you an example of how we are solving this in the Quillia network itself. And I'll also connect the dots with another project which does the same, but it's a very generalized system. Now, at the Quillia network, we'll have our own vetting of any agent that comes onto a network. So it's not like you can build any sort of agent which is going to perform its task like however you want. We are going to sort of do a sort of pre-audit before it goes on to our network live. But how you can ensure this in general that the AI agents do not go rogue is through something called a loss function. Now, BitTensor is a protocol which does this. Now, BitTensor is composed of subnets, and each of those subnets has a loss function. So, I would first like to give you an intuition about how AI works before I dive deep into it. So, AI is just about patterns. It's a function that maps a value A to value B. And loss function detects how far these two values are, how far the predicted values are. Let's say I create a very simple, I give you a very simple example. Let's say for a house that's 1,000 square meters, you're getting that for $1,000. For a house that's 2,000 square meters, you're getting it for $2,000, and so on. So our brains naturally try and predict the pattern that's going on. And if I ask you what's the price of the house, a 3,000 square meter house, you will be able to answer that. Now that's the intuition that we have, but but computers don't. So that intuition is created by a loss function. And that loss function is used in supervised learning to ensure that the outputs that are coming out of these AI systems is closer to our expected output. If there's a lot of diversion, then that means that the AI model is gone rogue. It is not working well. So that is one automated mechanism that you can use. But this loss function is very specific to the problem that you're trying to build. So in case of audits, we'll have to provide examples of how the audits should look like and what the produced outputs were. So by comparing the two in a supervised learning manner, we can ensure that the model is running correctly.
the model will be open or is it private? The weights,
So
the fine-tuned version. I mean, when we take a model and then when we fine tune it, the weights will be private, and when we are telling the contracts are coming in for the getting audited by the AI agents. So can somebody verify the model again? Were we open sourcing this in this aspect, the models?
right. So in the context of Quillia network, this can be completely open source. It's up to you whether you want to make it open source. So if you have the weights, but if you change the model in any way, we are again vetting it. If you're changing the weights of it, we are vetting it through our systems to make sure that it's performing the way. And we're also benchmarking them through our own methods. So those are the two things that we're doing to ensure that this works fine. But there's another aspect of how we manage this at Quillia network, which is pretty interesting. We call it the proof of security consensus. And what it does is, so I mentioned the use of trusted execution environments to make sure that these agents execute just as they should and nobody tampers with their code. If they do, we figure it out. The other is the measuring the correctness of the code. So let's say there are two agents which audit the same smart contract, and one of those agents produces 10 results, the other one produces 5. But the first agent which produced 10 results, let's say 6 of them turn out to be false positives. So what we are doing in proof of security consensus is getting a group of independent validators to, for now at least, manually vet how these agents are doing in terms of finding accurate results. And the better the results they have, the higher the ranking that they have in a system. So that's how we ensure that the agents themselves are competitive.
Okay. So there's a manual aspect here, a bit at least.
Yeah, for now at least, until we figure out a way to automate it completely. We cannot automate AI with another AI at the moment.
Yeah.
Cool. Any other questions from anyone? I would love to answer them.
Yeah, I had one question, but I think you had probably answered it in your session earlier, which basically was, what if one of the nodes that is operating the AI agent tool, or maybe the AI agent database, turns rogue, and or maybe has some malicious intent, and wants to take over some sort of structure there in the delivery system. So I'm sure
Right.
that is very yeah.
It comes down to TEs basically, and that's nothing specific to Web3 specifically. It's been done in the cybersecurity industry for years. All of our systems currently have it, and we also have something called a secure enclave. So the mobile phones and any passwords that you store, they actually are stored in a secure enclave where they cannot get out. So it's a hardware level requirement that we have to ensure to make sure that nobody tampers with the code and the AI does not go rogue. And a proof is generated and that proof basically proves that you executed their code in that trusted execution environment. If you did not, that signature will validate it.
Okay, so there's a question which has come in the chat as well. If you can just take a look at it, it talks about if we are incorporating AI agent for all this, what impact will it have on cost? Like, will it affect the pre-existing gas fees and all that? That's what Satakshi Singh has.
Okay. So one thing that we have to note is that we are not integrating these agents. Like there's no way to integrate these agents onto the blockchain itself. So I guess your question is answering more about what is the cost of running these agents and the whole network in itself. So that's something that we're still in the process of figuring out. Now, this boils down to two things. We have to ensure that the node operators who are running these agents, they're correctly incentivized, and the cost for running these agents, is kept low. And how we are doing that is we are providing an inferencing layer ourselves. So for the moment, while running these LLMs is expensive, we will be hosting them ourselves, and we will be providing them that through an API. And what the compute nodes are expected to do is just run an agent or a piece of code which infers from this API. So that is how we are ensuring that the costs are low. So of course there will be some added cost to your transaction, but that is going to come with a lot of security. So I guess I would take that.
Understood. Yeah. So if there are no more questions, I think probably we can call this.
Thank you for answering the question. And yeah, it's very interesting, this whole thing. I'll just check everything out. Is there any documentation or stuff I can refer to know more about it?
About the Quillian network or like decentralized AI in general?
No, Quillian network.
Okay, we don't have a public white paper out yet, but I can probably send you some material which is public. So you can share that. We'll have our white paper out by the end of this month. So we don't have to wait for a long time.
Okay, that's good to know.
Sure.
Thanks, Satakshi. Thanks.
I joined late, so I just had a question. You may have already addressed it, but still. So when you customize it for someone, let's say my company, will you be doing it yourself, or should we provide you the data? And one more thing, will that model be available to you to market to others as well, or will it just be for me?
Yeah. So I'll give you a brief intro of what the Quillia network is, because I feel like there will be a lot of these hanging questions and extra things that would come about. So we have two main participants in the network. One of them are agent creators, and the other one is the agent builder. So if you want something, some security that's specific to your case, you as an agent builder can opt in to create one for yourself, and that will be executed by the node operators that we have. So that's how our whole model is, and you can do that yourself. And how it works is each of the participants are incentivized. So every time there's a new task, we're calling it tasks in our ecosystem. Every time there's a new task in the network, it if it is executed by my agent, I as the agent creator get the incentive for it, and the node that is responsible for the execution of that agent also gets the incentive. So that's the whole process of how we're doing it.
All right, thank you.
Okay.
Thanks, Tesh. Yeah. Anyone else?
Yeah,
Well, I
hi
think.
Akshit.
Oh, okay.
How are
Please,
you?
please.
Hi.
Yeah, nice meeting with you. So, like, I wanted to know, like, I got the mail, like, I was reading about your project and all. So, what are your plans? Like, how much you have raised and what are you doing currently?
So we have raised around 1.5, and we are still in the process of raising. So we have a couple of rounds, and we already closed our angel round, and we have one at 25 mil valuation, which we are about to close, and another at 40 mil valuation. But I think you'll get a better idea about this if you connect with my other co-founders.
Yeah, like, it is great to hear that. Thanks a lot.
Sure.
And if possible, like, can we connect on Telegram anyhow?
Yeah, sure, surely. Definitely.
Can I have your ID or something, if possible?
Yeah, I think if I type this in the chat
We
here.
will. Yeah, you can chat. You can put it in the chat.
Okay. Sure. There you go.
Oh, you send me to on a direct message, so I will pass it on to the entire
Yeah.
group as such. Okay. So it's at the rate 0x Akshat. That's the Telegram for Akshat here. And in case you guys want to contact anyone from our side, these are the, you can just watch it in the chat itself. Okay. Yeah, I think we can. I think this is fantastic. I think there are a lot of things that we need to learn every time we come across a masterclass like this. And AI has been the go-to subject
Just,
for the last of a few weeks. Hello, anyone else
yeah,
ask a question?
yeah. Just one last question, if you don't mind. There,
Yeah,
hello.
Nidesh. Yeah.
Yeah. So the custom agents that we build, how much of the building process will we have to reveal to Quill AI? Will the entire model be with you, or maybe we can run APIs from my end? Or I mean, I just want to know
Okay.
the
So
autonomy that
we are
I
going
have.
with, yeah. So we are going with the progressive decentralization approach. As of now, from day one of a network, we will not have a strict requirement that you need to use these APIs. You need to do this. But what we will have to do is ensure that your code executes in a trusted execution environment and that it passes in our benchmarks. So even if you're not open sourcing your code, we will run a few tests in a sandbox environment. So it won't necessarily reveal the contents of your code and how you've done that. So that IP will be maintained, but we'll still ensure that it's performing as it should and it's not malicious in any way. So you'll be free to use some of the APIs and you'll have a lot of autonomy in building it. There's no specific framework or like a library or any language that you have to use, as long as it conforms to a network's protocols in terms of how it's communicating in inputs and outputs. You're good to go.
All right. Thank you.
Sure.
Okay, thank you so much, guys. I really appreciate everyone joining in and asking questions. Laksha, thank you so much for taking this session, and I hope everyone learns something out of this and is able to understand the concept behind decentralized AI and how AI can be are utilized to improve the Web3 security and eventually the trust in the Web3 space as such. I think we can call this a day. And if you guys want to reach out to Akshat, you can always reach out to him over LinkedIn as well. He's at 0x Akshat on LinkedIn. Akshat Mishra, he's the CTO of Quill AI Network and Quill Audits. You can find them there. And I've already supplied my social links for the company that I work with, is Pivot. Just to let you know, there'll be one more session that Quill AI Network guys will be taking, which is going to be post Diwali, which is going to be about a couple of weeks from now. And then from there on, we're going to be talking something about decentralized file storage using mobiles as a base equipment for Node, as a Node layer. And this team, we are accelerating them. They will also be working on a dedicated layer 1 for the mobile network. So I think that's something that probably we can look forward to. And, we can be working that way. Thank you so much, guys. Really appreciate your being around. We will look forward to seeing you again, Akshat, sometime later. Thank you so much, guys.
Thank you.
Thank you. Bye-bye. See you soon.
Bye.
Bye-bye. Bye-bye. Yeah.